Welcome back, students. We will be looking at section 2.4, practice problems for an introduction to applications of linear equations. So let's go ahead and get started. Number 1, we have if 4 times a number is added to 8, the result is 3 times the number added to 5. Find the number. All right, so let's first designate. Let number equal n. So we're going to be using n anytime it uses the word number in our problem. So it says if 4 times a number, so 4n, is added to 8, the result is, so the result is where we're going to put our equal sign. The result is 3 times the number, so 3n, added to 5, plus 5. And now it says find the number. So I will subtract 8 from both sides. I get 4n plus 0 equals 3n minus 3. So 4n equals 3n minus 3. I'm going to bring this back up over here. 4n equals 3n minus 3. Now I'm going to subtract my 3n. I get 1n equals 0 minus 3, which is just n equals negative 3. And we have found the number they wanted us to find. Okay. Number 2, if 2 is subtracted from a number and this difference is tripled, the result is 6 more than the number. Find the number. So again, we're going to say, let number equal n. So anytime it says the word number, we're going to plug in the letter n. If 2 is subtracted from, that's a turnaround phrase, a number. So we're going to say n minus 2 because it says if 2 is subtracted from n, and this difference is tripled. So this whole thing, this whole difference is tripled. So we're going to put it times 3. The result is, and that's our equal sign, 6 more than the number. So 6 plus that number. We're going to distribute and get 3n minus 6 equals 6 plus n. I'm going to add 6 to both sides and get 3n plus 0 equals 12 plus n. Bring that up over here so we have enough room to finish solving. We get 3n equals 12 plus n. Now I'm going to subtract my n from both sides. I get 2n equals 12 plus 0, which is 2n equals 12. Now I'm going to divide both sides by by 2, and I get n equals 6. And we have found our missing number. Number 3, if 4 is added to twice a number, and this sum is multiplied by 2, the result is the same as if the number is multiplied by 3 and 4 is added to the product. What is the number? There's a lot going on in this one, so we need to take it a step at a time. The first thing I'm going to do is say, let number equal n. Now I got to figure out how we're using that. If 4 is added to, so 4 plus twice a number, 2n, and this sum is multiplied by 2. So that whole thing, this sum here is multiplied by 2. That's what it'll look like. The result is, that's where we have our equal sign, the same as if the number is multiplied by 3, so 3n, and 4 is added to that product, so plus 4. All right, let's distribute. We have 8 plus 4n equals 3n plus 4. Subtract 8 from both sides. So I have 0 plus 4n equals 3n minus 4. Bring that up over here. 4n equals 3n minus 4. Now I'm going to subtract the 3n from both sides. I get 1n equals 0 minus 4. So n equals negative 4. And that's our answer. All right, number 4 is different than any of the examples we've seen so far in our notes and then so far in this practice problems. The first thing I notice is that there's an error on my screen that should be different from your page. This 7 should actually be a 6. Okay, so I'm going to go ahead and correct that. Your page should have a 6, but mine had a 7. All right, so now let's work on developing our pieces, our key that we're going to work from. An office manager booked 72 train tickets. He booked 10 more tickets on train A than train B. On train C, he booked 6 more than twice as many tickets as on train B. How many tickets did he book on each train? All right, so the first thing I notice is they tell us the total tickets he bought. So let's put that total equals 72. We have 3 trains. So I'm going to say let train A equal, let train B equal, and let train C equal. Okay. All right, so let's see how we know what's what. I do notice that they mentioned train B twice. So everything is referencing back to train B. They use train B to describe the amounts of the others. So that means train B is our reference point, and I'm going to make it just the letter B. Now let's figure out what it says about train A. It says it has 10 more tickets on train A than train B. So we're going to have B plus 10 here. Train C says it has 6 more, so 6 plus 6 more than twice as many tickets, so 2B is what we'll use for train C. How many tickets did he book on each train? All right, so to find a total of something, we would say train A plus train B plus train C gives us our total. So we're going to use this to form our equation. I'm going to replace the A with B plus 10 because that's what we designated as equaling train A. Train B is just B. And then train C was 6 plus 2B. And our total was 72. Add all my B's together and I get 4B. Add 10 and 6 and I get 16. All right, we have minus 16 on both sides. I get 4B plus 0 equals 56. That's 4B equals 56. I'm going to divide both sides by 4, and B equals 14. All right, so we know how many tickets were sold on train B, but we need to figure out how many are on train A and train C. I'm going to switch colors just so we know we're doing something different here. So we know that train B equals 14. Train A was represented by B plus 10. So we're going to substitute in 14 for B because now we know it's true identity, and that's going to give us 24. So train A was 24. Now let's look at train C. Train C was 6 plus 2B. So we'll replace the B with the 14. We get 6 plus 28, which is 34. So these are our 3 values for our train tickets. Number 5, an insecticide contains 84 centigrams of inert ingredient. So 84 centigrams of inert ingredient for every 1 centigram of active ingredient. If a quantity of the insecticide weighs 425 centigrams, how much of each type of ingredient does it contain? Okay, so the first thing I need to notice is that we have 84 centigrams of inert ingredient, okay, for every 1 centigram of active ingredient. This is our formula, basically, of how we would bake this cake if we were making a cake. We'd need 84 inert for every 1 active, okay? So how much total centigrams do we have? We have 85 total centigrams, okay? So that's one part of the problem. We needed to understand that part. Now we're going to look at how we solve this. So it's going to be part to whole. Remember, our fractions are part to whole equals part to whole. Okay, this is the pattern we're going to follow. Now I need to look back and see what exactly they're wanting us to find. It says how much of each type of ingredient does it contain? Okay, so it wants us to find the value for both of them, the inert and the active. So we're going to go through this problem twice, actually. All right, so let's start with the active, okay? We have 1 active for 85 total for whole. Remember, out of the whole, we have 1 active. On the other side, the part is what we're looking for. So we're looking for the active. We know the whole is 425. Okay. Now before we start, let me come back over here and just say, let active equal A and let inert equal I. That way we can remember what represents what. Right, now we're going to do what's called cross multiply. So we end up with 85A equals 425, because 85 times A is 85A and 1 times 425 is 425. Now we're going to divide by 85. Okay, so A equals 5. So we have 5 active in this particular amount. When we have a total of 425, 5 of those are the active ingredient. Now let's find our inert ingredient. We're still following the same pattern of part to whole equals part to whole. So 84 inert out of 85 whole equals I. We don't know the part of inert involved in 425 whole. So that's what we're looking for. Again, we're going to do cross multiplication. So I end up with 85I equals 84 times 425 is going to be 35,700. Divide by 85, divide by 85, and I end up with I equals 420 on the inert. Okay. So active equals 5, inert equals 420. If I add those together, I get the total weight of 425. So these are our answers. Okay. All right, let's look at number 6. If the sum of 3 consecutive even integers is 102, what are the 3 integers? So I'm looking for 3 numbers. I also noticed that they want us to find 3 consecutive even integers. And that's the pattern that we're going to be using of the x plus 2, x plus 4, that pattern that we learned in our notes. So I'm going to say let first number equal x. Let the second number equal x plus 2. Let the third number equal x plus 4. And the total they give us is 102. Okay. So remember our pattern when we want to find the sum is the first plus the second plus the third gives us the total. That's our formula. All right, x represents our first, so I'm going to put x. X plus 2 represents the second, so I'm going to put x plus 2. X plus 4 represents the third, so I'm going to put x plus 4. And then I have the total of 102. Okay, add all my x's together and I get 3x, 2 plus 4 is 6, equals 102. Subtract the 6 from both sides. I get 3x plus 0 equals 96. All right, I have 3x equals 96. Divide by 3 on both sides, and I get x equals 32. All right, we found one of our numbers, but now we need to find the other two. So let's see here. Our first number equals 32. The second number is x plus 2. So I need to plug that in and get 32 plus 2, which equals 34. Then I have my third number, which is x plus 4. Plug in my 32, and I get 36. So the way we would write this, remember, is we have 32, comma 34, comma 36. And that is, in fact, our answer. So I'm going to put a red box around this just so you know. That's the end of that particular problem. All right, let's scroll up to number 7. Number 7 says, find 2 consecutive odd integers such that 59 more than the lesser is 4 times the greater. Okay, so we're dealing with consecutive integers again. They want us to find 2 of them, and we're talking about odd integers. So let's first put out our key. Let the first equal x. Let the second equal x plus 2. So it says find 2 consecutive odd integers such that 59 more than the lesser. Okay, so remember the x is always our lesser number because when we count in order, we count up, right? So they're saying that 59 more than the lesser. So x plus 59. And then it says is, so that's equals, 4 times the greater. So the second number is always going to be greater than the first number because, again, we're counting in order. So they said 4 times that. So 4 times x plus 2. Now we can distribute. So I have 4x plus 8. I'm going to subtract 59 from both sides. I get x plus 0 equals 4x, and then, that's going to give us negative 51. So I have x equals 4x minus 51. Now I'm going to subtract the 4x from both sides. I get a negative 3x equals 0 minus 51. Bring that up over here so I can finish it. Divide both sides by negative 3. Then I get x equals 17. Now I need to find my other number, basically. So I have, let's see here. Our first number is 17. Our second number equals x plus 2. So 17 plus 2 gives us 19. So our two numbers are 17, 19. Number 8. If 5 times the lesser of 2 consecutive integers is added to 3 times the greater, the result is 59. All right, so we're looking for 2 consecutive integers. So that's going to be let the first equal x, let the second equal x plus 1. Plus 1 because we're not doing odd or even, we're just doing normal consecutive. Now let's see what they want us to do with these. Okay, so if 5 times the lesser, all right, so x is our lesser, so 5x. So if 5 times the lesser of 2 consecutive integers is added to, so we're adding it to something, 3 times the greater. So 3 times, the greater is our x plus 1. The result is, so equals 59. Find the integers. All right, so let's distribute. We get 3x plus 3 equals 59. Add our x's together. We get 8x plus 3 equals 59. Subtract the 3. We get 8x plus 0 equals 56. Let's see, rewrite that. Divide both sides by 8. I get x equals 7. All right, so we know our first number is 7. So now I need to come over here and say, okay, so x is 7. So our second number equals x plus 1. So 7 plus 1 is 8. So our two numbers is 7, 8. Number 9. Find the measure of an angle whose complement is 5 times its measure. So remember, complement is represented by 90 minus x. And then our supplement, so that's the complement, our supplement was represented by 180 minus x, just as a review. So this says find the measure of an angle whose complement, so 90 minus x, is, that's equals, 5 times its measure. So 5 times the measure is talking about the x. So 5 times x. Bring out our 90 minus x. I'm going to add my x to both sides. I get 90 plus 0 equals 6x. Rewrite that. Divide both sides by 6. And I get x equals 15. And that is our answer. All right, let's look at number 10. We have find the measure of an angle such that the sum of the measures of its complement and its supplement is 160. All right, so they want us to add the complement and the supplement. So our complement is 90 minus x added to the supplement, which is 180 minus x. And they tell us that that results in 160 because they say is 160, so equals 160. Bring both of those out of the parentheses. So we don't have any negatives that we need to multiply against it, so nothing would change. All right, let's combine our x's. Negative x minus x is going to be negative 2x. 90 plus 180 is going to give us plus 270 equals 160. Subtract 270 from both sides. Get negative 2x plus 0 equals negative 110. Bring that up over here. So negative 2x equals negative 110. Divide both sides by negative 2. X equals 55. And we have our answer. All right, last example problem. Number 11, find the measure of an angle such that twice its complement, so we're going to be finding something about a complement, is 30 less than its supplement. So we're going to be using both of these. All right, so find the measure of an angle such that twice the complement. Well, the complement is 90 minus x, and it tells us we're going to twice it. So I need to multiply it times 2. Is, so equals, 30 less than, that's that turnaround phrase. So now I'm going to be subtracting 30 from something. So 30 less than its supplement. So supplement goes in the front of that. So 180 minus x. Go ahead and distribute. I have 180 minus 2x equals 180 minus x minus 30. Combine like terms where possible, which is the 180 minus the 30. So that gives me 150 minus x. Now I'm going to subtract my 180 from both sides. I end up with 0 minus 2x equals negative 30 minus x. Add the x to both sides. Or here, before I do that, let me rewrite it. I forgot that part. So I have negative 2x equals negative 30 minus x. Okay, add my x to both sides. I get negative 1x equals negative 30. We can't leave our x negative, so we need to divide both sides by that negative 1. So our answer is x equals 30. All right, guys, that's all of the examples for this section. Let's read our memory verse. Do not be afraid or discouraged, for the Lord will personally go ahead of you. He will be with you. He will neither fail you nor abandon you. Deuteronomy 31:8. I hope this verse has been encouraging to you in this section. See you in the next video, guys. Bye.